This is assignment 6-2. Find the finished floor elevation and create drainage around the building pad. So that's the task we're going to do for this exercise. This is your building pad. FFE stands for finished floor elevation. The entire pad will be flat. So whatever this elevation is, that will be the elevation of all four corners. This dashed line, that is the slope away from the building pad at 2% for 5 feet. That's what that represents. HPS, remember that's high point of swell, is 5 feet from the edge of the 5-foot clear area. That's this X right here. Provide rim elevations at the drain inlets. And those are down here. And there are two swells. You can't see it, it's just off the page, but north is straight up. And they say the longitudinal slope of the eastern swell, that's this side, is 3%. Longitudinal slope on the western swell is 4.5%. That's this one. So the maximum slope is 4 to 1. With that, let's go ahead and get started. One of the things they do in the book is to show you, they're trying to show you how to find the finished floor elevation by just basically finding out what the existing grade is halfway across your pad. And by doing that, they interpolate for this spot elevation and this spot elevation down here. They interpolate so that you can so you can calculate those spot elevations by doing, this is one, ignore the pad right now. Let's just talk about the existing grade. And the existing elevation, this corner, lands right here, and it's between contour 42 and 43. So it looks like it's about a quarter of the way, and you could guess that that's probably about elevation 42.25 would be my guess. But you can interpolate and get that exact point by scaling off, figuring out what the slope is right here. You can calculate what that spot elevation is. I think for this assignment that's a bit overkill, and so to save us time and kind of get going on this, finished floor elevation, you basically want the center, the pad, you want to minimize your cut and fill, so you want to be able to kind of cut half the pad and take that dirt and fill the bottom half. And by doing that, you just kind of get as close to the midpoint. With the midpoint of your building, you try and get as close to the existing grade as you can. And if you look at this, it's right in between. This is basically the center of the building pad. This is elevation 40, elevation 41. So if we set that pad, that existing grade right there, about halfway between 40 and 41, would be 40.5. And we're going to use that as our finished 40.5. We're going to use that as our finished floor elevation. It's just that easy, and that is the way to do that just quickly. So 40.50 we'll say as our pad. So hopefully that makes sense. Now let's go ahead and just do our grading problem. They say that the slope away from the building pad is 2% for the first 5 feet, so that's from here to here. So we want to know what the vertical drop is from here. All four corners are 40.5. This whole thing is 40.5. So now we're just going to go 5 feet at 2% and assign that elevation to these corners. So we're looking for, to write it up here, we're trying to find what our vertical is, which is horizontal times slope. We're going 5 feet horizontal. Multiply that by 2%, 0.02, and you get 5 times 0.02 is 5 times 0.02 equals, again, I've got to move my solar calculator to the light. 5 times 0.02 equals 0.1. So if this is 40.5 at all four corners, this is going downhill. We lose 0.1 feet. So our corners are going to be 40 instead of 0.5. Now we're going to have 40.4. I'm just going to write that on the inside here. I don't want to try not to block my light so this doesn't. 40.4. And this corner here is the same, 40.4, 40.4, 40.4, and then we're going to drop, so that's these corners. Then we're going to drop, they say the high point go another 5 feet, and that's at 2% as well. So 5 feet at 2%, that's another 0.1. So now we're going to end up with the high point of our swell at 40.3. So we took, from this elevation, we took 0.1 from here, and that's the elevation we got here, which is 40.4. Took 0.1 from this and got 40.3 for our high point of our swell. So now what we can do, let's go ahead and just kind of draw in our swell just as a guideline, right? Something like this. It'll be as close as we can, right? So we're going down to this drain inlet, and then we got to do the same thing over here. We have to go around and down here. So those are our two swells, and we just roughed them in as a guideline. Now what we can do, let's go ahead and draw the contours. We know there's going to be, well, let's do our spot elevations here, and then we'll draw our contours around our pad. So if this is 40.3, start at the high point. It's just like doing the center line of a road. You're going to go now, we got to find elevation going downhill. Next whole contour is going to be 40. So it's 0.3 lower. So let's do, we're trying to find the horizontal distance from 40.3 down to 40. Horizontal equals vertical divided by slope. Vertical is 0.3. We're going to drop 0.3 feet, and we're going to divide that by our slope, which the slope of this swell, this is the east, this is the west. They say that the eastern swell, northeast, so the western swell, out there, this is 4.5%, 4.5%. And this one is 3% over here. So let's figure out 0.3, we got to go at 4.5%, which is 0.045. That equals 0.3 divided by 0.045, 6.66, 6.7. So we'll go 6.7 feet right there. That is number 4, contour 40. We'll just write it right here, 40. Then, now we're going to go 1 foot at that same, because now we're at 40, we got to get to 39. So let's do 1 divided by 4.5% equals 1 divided by 0.045, 22.2. So we'll go 22.2 feet right here. That's 40. This is 39. Then we'll go another 22 feet, which puts us right here. 22 feet. And another 22 feet after that. So now we've got 39, 38, 37, and let's measure the distance. We need to measure this distance to figure out what our elevation is here. It's a little tricky because to be 4.5%, we'd have to go, this may be a little shallower down here because this is, everybody's swell is going to be slightly different length. Let's measure this one real quick. It's roughly 20, 40. I'm going to say that's about, let's say 85 feet. So we've got 85-foot swell on this side. And then on this side over here, we're going to go, that's 40 feet, and then let's do real quick, that's 40, we'll do another 5, that's 50, 70, so 110, 15, 16, 17. So we'll call this one 117 feet over here. 117 feet. So now we're going 85 feet on this side at 4.5%. So let's find out what our vertical, horizontal times slope, let's find out what the rim elevation of our drain is. So we're going 85 feet times our slope, which is 0.045, 0.045 equals. So 85 times 0.045, 3.825, 3.825. So we'll subtract that vertical from this elevation, and we get 40.3, 40.3 minus 40.3 minus 3.825, 3.825, 36.475 or 36.48. So our rim elevation is 36.48. So that makes sense because 36.48, so 37 goes around our drain. And we don't go to 36 because 36.48 is as low as we go. So let's do the same thing over here on this side. We've got 117 feet now. 117 feet times 3%, 0.03 equals 117 times 0.03 equals 3.51. 1 feet. So this drops from 40.3, it drops 3.51 feet. So let's subtract, we'll take 40.3 minus 3.51 equals 40.3 minus 3.51, 36.79. 36.79. So it drops from here to here. The rim elevation is 36.79 feet lower. So let's take 40.3 and subtract minus, oops, what did I do? I wrote that down wrong. No, 36.79, sorry. 40.3, we subtract 3.51, because that's what our vertical drop is. We get 36.79 rim elevation. 36.79. Oops. Right, 76. 36.79. Now, see, just like this, if it was a center line of a road, same thing, center line of a swell, 40.3, we got to go drop vertically 0.3 to get to the 40 contour. And that's 0.3, except now we're going 0.3 divided by, now we're using 3%. 0.03 equals 0.3 divided by 0.03 equals 10. So you just go 10 feet, measure over 10 feet, and that's 40 on this side. And then if that's, now we've got to drop, now we're going to drop a foot divided by 0.03. You know, for 0.3 we drop 10 feet. Should have wrote that down for you. Now we're going to go 1 foot vertical, right, from 40 to 39 at 3%. 3%. So 1 divided by 0.03, 33 feet. So we just measure 33, it's equals 33.33. 33.33 feet. So we're going to measure 33.33 feet about. That'll put us right here. That's 39. Then we got to go, that's about 20. 33.33 is about right there, so that's 38. We're going to go another 33, right about there, and that's 37. And then this is 36.79, so those are all our contours. So now, this is 40.4. How far horizontally are the contours going to be away from this? Well, they say that our maximum slope is 4 to 1. 4 to 1 is the same as 25%, right? If you divide 1 divided by 4, you get 25%. So 1 divided by 4 equals 25%. 0.25, the same thing. So we want to go 0.4 feet. We want to find the 41 or the 40-foot contour because it's 40.4. So now we're going downhill, all right, draining away from this pad and the flat area at 4 to 1. We got to go 0.4 feet vertically. So 0.4 feet vertically and divide that by our slope, which we said is a 25% slope. So we'll go, we're going to write it here without going off the page. 0.4 feet, that's that, to drop to 40, divided by our 0.25 equals 0.4 divided by 0.25, 1.6. That equals 1.6 feet. So to get to the 40-foot contour, it's going to be 1.6 feet away at 4 to 1. We could go further, but a minimum of 1.6. So let's just do like this. We'll draw 1.6 or 2 feet. I'm going to draw a line right across here. So that is contour 40. And then 40, and then we got to go 39, 38, 37. And each one's going to be 4 feet away because they say up here, maximum slope is 4 to 1. So now we just go 4, 8, 12. Another one, 4, 8, 12. $40, 39, 38, 37, and then 37's here, and then another 37. That's week 38. So we can almost go, we almost don't need the 37, do we? So we actually don't really need the 37 because 37's down here. So we don't need 37. So that's as far as we gotta go, 38. So now we gotta do the same thing. Now here's 40 way up here, and here's 40. So we gotta go, remember we said it was 1.6 feet away from here to here. It's gonna be the same on the sides. So let's go ahead and draw that contour. It's gonna be 1.6. So I'm just gonna do 2 feet because it's easy. So this would be 40-foot contour, and then I gotta go every 4 feet. So there's 4, because there's 39, there's 38, so there's gonna be 4. So this is, that's 40, so this is 39. Just drawing them 4 feet apart. I have to go another 4 feet. Now this is 38, so I only have to go up this far. So I don't have to go beyond it because 38's there, and I'm drawing the 38-foot contour. So it goes like this. So now I'll connect these. All right. So this is 38. 38 ties in here. 39. It's got to be 4 feet away here at the, so we got to go 2 feet. Let's do this. We're going to go 1.6 feet, and we're just rounding up to 2. We got to go around the corner here. So this is 40. See it? Follow that contour of 40, goes all the way down. See 40 there? So now we've got to take 37, this rim elevation 36.79, and so we've got to stay, it's 4 to 1. So let's do this. Again, 4 to 1 is 25%, so the closest we can get. So for contour 37, we are going to be, we're going to go 37 is 37 minus 36.79. 37 minus 36.79. We got to go 0.21 feet vertically to get to contour 36, right? So at 4 to 1, which is 25%, we're going to go 0.21, because that's vertical distance to get to 37 from 36.79. We divide that by 0.25 because maximum slope's 4 to 1, which is 25%. That equals 0.21 divided by 0.25. 0.25 equals 0.84, 0.84. So with the 37-foot contour, we have to stay about at least a 0.84, so a foot away from this rim elevation. So as long as we stay, you know, out here like that, we are fine. Same thing on this side. It's 0.48, so almost a half a foot to get to 37. So half a foot would be 2 feet at 4 to 1, right? So we're gonna, or 4 feet, actually half a foot, yeah, 2 feet. So we'll just measure 2 feet around like that. Those are 30 foot, so we 37-foot contour. To get to 37 from 36.48 is about half a foot. So if it's 4 to 1, so 4 feet for every 1 foot, for half a foot, it'd be half that amount, so 2 feet. That's why we stayed 2 feet away from the rim with this contour. Now 38, let's do the same thing over here. We gotta go clear up to 40. We have to stay 1.6 feet away, and we're just using 2 feet, we're rounded up. We got that 1.6 from here, because we have to stay 0.4 feet away from this line, right? At 4 to 1. Hopefully this is kind of making sense. And then we gotta come around, connect it, and it goes like this. So there's, then we gotta do 39. 39 has to stay 4 feet away. So we'll do this. We're gonna kind of like that. Our swells, we could tighten up the swell, but we're not gonna, because 38, 4 feet, 4 feet. I'm staying 4 feet away, which is here. So we're just gonna go 38. We gotta come around like that. Okay, so now we've done our swell. This side we gotta go 39 to here. We gotta stay 4 feet away. So we gotta go like this. Oops, like that. And then we've got all those. Now we've got to connect 38. We gotta stay, we gotta tie into 38 with this 38. Staying at least 4 feet away, because it's 4 to 1. So as long as we do something like this, right? I'm staying 4 to 1. These are 4 to 1, which is what they've given us in the directions right there. Same over here, 4 to 1. So now I'm just connecting. I gotta stay here. I gotta tie 39. 39, I gotta stay at least 4 feet away. So that's here. Right, so I'm gonna come down, stay 4 feet away from this contour, like this. Right. And then this one, I gotta stay 4 feet away. 4 feet, and it's gotta tie into here, 40. 40 has to tie in here and come clear up here. And I gotta stay 4 feet away. So that's right there. And come around here, like that. Now let's draw in our swell a little bit better. See our arrows. Don't forget to draw in the center line of your swell. Also, do not forget to put your slope of your swell, which in this case is 38% or 3.8%. No, that's contour 38. Where's my swell? This is why you have to write it down. They say the east contour swell is 3%. So we got to write 3%. That's given right there, 3%. This side over here, it's 4.5%. So now we got to tie these in. We got to stay 38 to 38. We got to stay 4 feet away. So we got to come down like this. And then this one, we got to stay here and like that. And let's move our 4.8 into here, 4.8%. And we're going to take it off right here so that we can draw the center line of our swell. Let's just draw this like this. There. And then 39 has to tie into 39 down here, which we did. 40 has to tie into here, so we got to stay, again, 4 feet away, 4 to 1. So if we just come like this, that. All right, so we've got our 2 swells on each side. Everything's good down here. Up here, we just have to see 41 now crosses under the 39-foot contour. So we've got to bring it around, and we have to stay 4 feet away. So that's this. So we have to come, we're just not going to draw over that. So like this. And then this is 40, this is 41. 41 has to go clear over here. So it's got to come around like that. And then 42 has to stay 4 feet away. Like that. Around, we're going to come around 42 like that. So this is contour 41, contour 42, contour 43 is another 4 feet. So we're staying 4 feet away. This is 43, and then we got to come clear over to here. Again, we're staying, as a reminder, we're staying, 4 to 1. That's our maximum slope there. So we're showing, we can even write 4 to 1 max. Now we have 44 crossing 43, so we still got to do that one. So we're going to do one more. And that is like that. There's 40. 40 comes around. Ties in right there. There's 44. And then 45 is not crossing any contours, so it's fine. We've met grade. And there's the, that's how you do this problem. So you got your pad with a horseshoe swell around both sides. Don't forget to draw in the center line of your swell. Put the slope of the swell. Label the uphill side of your contours. Put hashes where you tie into your existing contours. Label your rim elevations. And label your finished floor elevation. And that's all there is to it.